Hugo is giving a piece of cardboard to make a tray. It is 16 centimeters by 10 centimeters, and he will be cutting out squares in order to fold the sides and make a tray. Hugo will be cutting out 4 corners in order to make the tray. The corners, labeled X, have 2 equal sides, being that they are a square. We will find both the length and width of the rectangle in terms of X. We will be finding the length and width in terms of X. In order to do this, we have to subtract the X, which is the length and width of the square, from the total length and the total width of the rectangle. This will give us the value when the squares are cut out. No, the value of X cannot be 5. For example, if you multiply 2 by X, which are the squares that you cut out from the corners, and subtract it from the total width, which is 10, your answer would be 0. It is impossible to have a width of 0 when there is still cardboard remaining on that side. X cannot be a value less than 0, or else it would not make sense to cut out a side of a length of 0. However, it cannot be greater than 5, or else you would be cutting out the whole side and not have any left over in order to fold the tray. We will be using the volume formula of a rectangle in order to find the volume of the tray. We will be using the area, which is the length times width, which was found in part A, and we will be using the height, which is X. We then will multiply the 3 together in order to get our volume. The first step is multiplying the length times width and getting a quadratic formula. Then we distribute the X into the problem in order to get the full volume together. However, this is still in terms of X, being that we do not know the volume of X just yet. As shown, when we distribute the X, we get our cubic formula for the volume. For this part, we will be finding the derivative of the equation in order to find the max volume of the rectangular prism for the next part. In order to find the derivative, you need to multiply the exponent by the coefficient, and you will get 12 in this scenario. Then you will subtract 1 from the exponent, in this scenario being 3, and you will get 2. You then proceed to do this for the next 2 numbers, and you will get your final derivative.
In order to find the X value that maximizes the volume of the tray, you need to set the derivative equal to 0 and plug the derivative at 0 into your calculator.
A graph should find up, and then you will need to find the intersection of the graph with the x-axis. You do this by going to Second, Calc, Intersect, and see where it intersects. As you can see, it intersects at 2 places. However, as shown in previous problems, the value of x could only be 0 to 5, not including 5 and not including 0. Therefore, 2 is the only solution and only value of x. Being that 2 is the value that maximizes the volume of the tray, we need to plug in 2 for x into the derivative equation. This will give us the maximum value of the tray. When the math was done, it came out to be 144 centimeters cubed. This is the max volume that could fit into the tray. For the final problem, we will be graphing the equation v equals 4x cubed minus 52x squared plus 160x. This graph will verify our previous answer to the question of what is the maximum value of the tray. As you can see in the graph, the turning point of the graph is 144 centimeters cubed. This shows that the tray can only hold 144 centimeters cubed. The graph only asks for us to graph points between 0 and 200, including both 0 and 200.
Thanks to our great math skills, Hugo's tray works amazing.